Hello class 8 students, I hope everyone is doing well. So today we are going to start the lecture number 5. Here we will discuss persistence of vision and range of vision. Now let us see persistence of vision. The image formed on the retina of the eye does not fade away instantaneously, but its impression remains on the retina for about 1/16th of a second, even after the removal of the object. Okay guys, now we know that image is formed on the retina of the eye, and the image which is formed on the retina, it does not fade away instantaneously, but its impression remains on the retina for about 1/16th of a second, even after the object is removed. So this continuance of sensation of vision is called as persistence of vision. Clear everyone? Now let us see an experiment. So take a plain cardboard. Now on one side of the cardboard, you can either draw or paste the case. Can you see here? Okay, now on the other side of the cardboard, similarly you can draw or paste the bird. Now rotate the cardboard and observe closely. Can you see the magic? Yes, you can see the bird inside the case, right? So this is because of the persistence of vision, that when still images of a moving object are flashed on the eye at a rate faster than 16 per second, the eye perceives this object as moving. So now when we look at an object, an image of it is formed on our retina, right? So this image persists on the retina for 1/16th of a second, even after the object is removed. Now since the bird and the case are flashed at a rate faster than 16 times per second, so we can see a combination of both images. Now let us see another experiment. The movie or program that we see are actually a number of separate still pictures in proper sequence. So in this experiment you can see that a man riding a horse, right? But actually a man is not riding the horse. It is a number of separate still pictures in proper sequence. Can you see here? Number of still pictures which are in proper sequence. Now see, it is sequence of still pictures taken by a movie camera that is projected on the screen at the rate of 24 images or more per second. Now the movie camera takes still pictures which is then projected on the screen at the rate of 24 images or more per second. The successive impression of the image on the eye retina appear to blend or merge smoothly into one another. We therefore see a moving picture. Now one after another, the impression of the still image on the eye retina, they appear to blend or merge smoothly into one another, and this is how we can see a moving picture. This principle is used in cinematography or motion picture projection. Alright, now let us see the range of vision. The minimum distance at which objects can be seen most distinctly without strain is called the least distance of distinct vision, or near point of the eye. So this is the definition for near point of the eye. It means that the minimum distance at which we can see any objects most distinctly, that means without any strain. So it is called the least distance of distinct vision or near point of the eye. Now for a young adult with a normal eye, this normal near point distance equals almost 25 centimeter. So with normal eye in case of young adult, this normal near point distance is almost equal to 25 centimeter. The farthest point up to which the eye can see objects clearly is called the far point of the eye. So the farthest point up to which we can see objects clearly, it is called far point of the eye. And the distance far point of the eye, it is at infinity for a normal eye. Alright, as you can see, it is at infinity for a normal eye. That means very far away. The distance between the nearest point and far point of a normal eye is called the range of vision. It thus varies from 25 centimeter to infinity for the normal eye. Now range of vision means the distance between the nearest point and far point of a normal eye. Alright, and it varies from 25 centimeter to infinity for the normal eye. Clear everyone? Now let us see how we can see far away objects. To focus on distant objects, the ciliary muscles relax, making the eye lens thin. Okay, now see here, ciliary muscles are present over here, and this is the lens. As you can see here, to focus on distant objects, the ciliary muscles, they relax and making the eye lens thin. Can you see it? As a result, the focal length of the eye lens increases and we can see the distant objects. And as a result, the focal length of the eye lens, it increases, and thus we can see the distant objects. Now let us see how we can see nearby objects. To focus on nearby objects, the ciliary muscles contracts, making the eye lens thick. Now see here, to focus on these nearby objects, the ciliary muscles contracts and making the eye lens thick. Can you see it? As a result, the focal length of the eye lens decreases and we see the nearby objects. After making the eye lens thick, the focal length of the eye lens, it decreases, and this is how we can see the nearby objects. The ability of the lens of adjusting focal length is known as power of accommodation. So power of accommodation means the ability of the lens of adjusting the focal length. Alright, next we will discuss visually silenced persons, help for visually silenced persons, and we will also discuss about Braille. Now see this, is not this beautiful? Okay, so first we will discuss visually silenced persons. So vision problem can be due to some illness like diabetes. So this is normal eye and this is eye of a diabetic patient. So it is called diabetic retinopathy. Now see here, in diabetes retinopathy, it is caused by damage to the blood vessels in the tissue at the back of the eye, that means at the retina. So poorly controlled blood sugar is a risk factor and even blindness can occur. Next, see glaucoma. In glaucoma, there is low vision loss and it is a chronic disease. So basically it is caused by damage to the optic nerve which leads to visual field loss. Then see cataract. Most probably you have heard this term, right? So a cataract develops when the lens in our eye, which is normally clear, it becomes foggy. Now see here, this is a normal eye and this is a cataract eye. So in case of normal eye, the lens is clear, whereas in case of cataract eye, the lens is foggy. Can you see here? And it blocks the light as it passes through the lens. As a result, our vision becomes blurred. Vitamin A deficiency. So if there is a deficiency in vitamin A, then we might suffer from vision problem. So we must always eat fruits and vegetables which is rich in vitamin A. Clear everyone? Vision problem can also be genetic or inherited. That means transferred to kids from parents through their genes. So vision problem can also be transferred to kids from parents through their genes. In some unfortunate cases, some persons lose their vision due to some accident. Suppose if a person's optic nerve got damaged in some accident, then the person may lead to vision loss. Okay, now see here, there are two types of loss of vision. One is partial loss of vision and the other is complete loss of vision. Hence, all visually silenced persons cannot be educated or treated alike. Most visually silenced persons have a better sense of touch, smell or hearing than the normal people. Alright, now most of the visually silenced persons, they have a better sense of touch, smell or hearing than the normal person. So such persons, they try to identify things by developing their own senses more sharply and putting them to effective use. So such persons, they identify things by developing their own senses more sharply and by putting them to effective use. Now let us see help for visually silenced persons by non-optical aids and by optical aids. So first we will see by non-optical aids. So tactile aids, that means using sense of touch. Example Braille. Now in this system, make use of raised dots on a paper. So here some dots are raised on a paper. So another non-optical aids like through auditory aids, that means by using sense of hearing. Example audio cassettes, tape recorders and audio CDs, etc. Now say optical aids like lenses and telescopic aids. Clear? Well, can you read this? Definitely we cannot read this. but around 10 million people across the globe can read these lines. So it is written Louis Braille. Now I'm going to narrate a short story. In fact, it is a true story. So here it goes. 200 years ago, a little accident changed the world of little Louis. He lost his eyesight in an accident when he was 3 years old, and that was the last time Louis had colors in his world. After that, he had only darkness in his life. However, this was not the end of his learning. Louis loved reading, but his inability to read was his huge obstacle. Louis harnessed his use of touch to overcome his loss of vision. One day, Louis touched a piece of paper which felt different from all the other paper he had felt. It had bumps. So this led to the invention of Braille. Now, Braille is a system of raised dots that can be read with the fingers by people who are blind or who have low vision. Now see, Braille, it is a system where raised dots are there so that it can be read with the fingers by the people who are blind or who have low vision. A blind person who led a lot of blind people to read and write. So now see how a blind person who led a lot of other blind people to read and write. Now let us see the Braille system. So in Braille system, basically it is a coded language based on a logical system. There is a Braille code for common languages, mathematics and scientific notations. As you can see here, this is a Braille code for the English alphabet. That means the Braille alphabet. And this is the Braille code for numerical sign. Can you see here? So it is the Braille code for mathematics. Many languages, foreign or Indian, can be read using the Braille system. So by using the Braille system, many Indian or foreign languages can be read. Braille system has 63 dot patterns or characters. So this Braille system, it has got 63 dot patterns or characters. To make them easier to touch, the dots are raised slightly. So to make them easier to touch, the dots, they are raised slightly. These patterns, when embossed on Braille sheets, help visually challenged person to recognize words by touching. So with the help of these patterns, it helped the visually challenged person to recognize words by touching. Braille text can be made by hand or by machine, like through printing machine or typewriter. Okay guys, I hope everyone is clear and we are done for lesson number 5. Thank you.